This film presents one approach to the role assumed by the system's maintenance sector personnel during flight inspection periods. Its purpose is to show the technician how the functions of ground and air personnel are correlated. No implication is intended to suggest that the procedures shown are the only correct ones. Only highlights are covered, and prior technical knowledge is assumed. The Federal Aviation Agency requires frequent checks of each system concerned with any phase of flight operations. One of the most important of these is the instrument landing system. The ILS is to be flight inspected. The system's worthiness is the responsibility of the men assigned to this office. How are the system characteristics measured and, if necessary, corrected during flight inspection? And what must be done after a flight inspection to assure future ILS reliability? Let's observe the ILS maintenance personnel as they prepare for their assignment. Aircraft flight time is expensive. Therefore, efficient and successful flight inspections are important and must be conducted by competent and properly trained personnel. The ILS localizer will be inspected first. The section chief clears with ATC for establishing outage time and notice to airmen. He plans for the event by scheduling sufficient personnel and readying the facility. He thinks of all the necessary things: vehicle transportation, the availability of adequate two-way communications, the autolite if needed. Since there is sufficient time before the arrival of November 6-7, a check of the facility subsystems will be made in this order. The transmitter is the beginning of the localizer system's tune-up. The resonance of each stage is checked. And precisely adjusted. The sideband generator must be at its optimum condition. Plate tuning good. Optimum coupling. Coincidence of this pattern indicates no carrier in the sideband output. Also, the cathode currents are balanced as required. With a well-balanced modulation bridge, a negligible amount of the navigational frequencies are allowed in the modulator output circuit. Less than 10%, well within limits, and therefore a good balance. Proper hybrid bridge balance assures isolation of the two navigational frequency sources. Here, the unbalance shows within limits. Then the modulation percentage is checked by observation of the scope. The output transtat on the motor alternator unit is properly adjusted. Equality of modulation is achieved by using the balanced transtat. The next step will be to phase the system. The goal in optimum phasing is to place the individual sideband radiations in proper phase relationship with the carrier. The prescribed quadrature method is used. A 90-degree section of line is added to the carrier feed system. And all sideband lines, except the one to the radiating pair, are terminated in dummy loads. Meantime, an assistant locates an ILS truck at a point about 2,000 feet from the antenna array and 5 to 10 degrees off course. Two-way communication keeps the man in the localizer building advised of proper quadrature phasing, as shown by an on-course indication of the ILS truck receiver. Upon completion of the phasing checks, the 90-degree section of line and the dummy loads are removed. And the tower clears the ILS truck to enter the runway. The truck now proceeds to the designated runway positions for a ground reference check of course alignment and course width. Here, a ground reference alignment check is being made. Note that the indicator deflection is varying slightly. This reveals very little irregularity in course straightness. Now, the indicated course width and course alignment are being measured at the predetermined points on the runway. These will later be confirmed with the portable field and course detector. The facility is readied, and the men are now prepared for an efficient flight inspection operation.
Localizer, November 6-7.
November 6-7, Localizer ground crew. Go ahead.
November 6-7 is proceeding outbound to make a usable distance check.
Number 1 equipment is in operation. Ground crew standing by.
Roger. Will advise when check is completed.
What characteristics of the localizer will be flight inspected? This depends on the type of inspection, whether it's a commissioning, a site, a special, a periodic, or an operational flight inspection. This facility is scheduled for a semi-annual periodic inspection. These, then, are the items that must be observed. Usable distance. This determines that the signal is usable at least 25 miles from the localizer. Identification indicates clarity and that the keyed characters are correct and properly spaced. The voice check determines that the voice modulation will not disturb the on-course indication when flying inbound. The voice must be crisp and of the correct level. The 90 and 150 cycle modulation is determined by the level of flag current measured on course. The radiated course should bring the aircraft precisely to the runway center line. Also, the course width must meet specified tolerances. Differences in depth of modulation at all points out of the course sector should be sufficient to provide full-scale deflections. Fly left. Or fly right. The polarization effect is checked. Does appreciable deviation from on-course occur with movement of the aircraft about its longitudinal axis? Now the monitor system. It should reveal system malfunctions, course misalignment, and course width changes. The objective is to provide an accurately adjusted and absolutely safe ILS localizer facility. The personnel of the ILS inspection aircraft, designated as November 6-7, must determine if a usable signal is available 25 miles from the localizer. It is a check performed by flying perpendicular to the course from plus 10 degrees to minus 10 degrees, and then along the course inbound in search of unwanted low signal areas. The identification and voice are also checked at this time. The identification characters are correct. The spacing and the clarity are good. The tone and the level are normal.
ILS flight inspection. 1, 2, 3, 4, 5, 6, 6, 5, 4, 3, 2,
The team now centers on voice modulation. It is clear and the level is sufficient. It sounds approximately equal to the identification signal. No interference is observed of the on-course indications due to voice modulation. Next, as the aircraft continues down course, the amount of 90 and 150 cycles per second modulation is measured. When rectified, in the airborne receiver, these modulation components determine the amount of flag current. If modulation should decrease, then the indicated usable distance would also decrease. On the ground, the measurement is straightforward. In the aircraft, it has to be made a different way. It has to be determined by measuring the flag current. Since the depth of modulation determines flag current, a measurement of flag current indicates the depth of modulation.
Localizer ground crew, your modulation percentage is 20.
Roger, November 6-7, that's what we read.
We're flying out for a look at the course width.
Okay, standing by.
The course width must be exact. If it's too wide, the approach indications would be insensitive. If it's too narrow, the course becomes difficult to fly. The width of the course, that is, the angular measurement between the two limits of full fly left and full fly right, is usually determined like this. A checkpoint for which the distance from the localizer site is known is selected by the aircraft, which flies at a specified altitude, flying perpendicular to the extended runway centerline. Precise note is made in the plane of the effective true airspeed and the time in seconds to traverse from 150 microamps fly left to 150 microamps fly right and return. Here we approach an edge of the course.
Localizer, November 6-7. We've just completed the course width run. Your course width measures 5.2 degrees.
Roger, November 6-7. We'll correct it. Stand by.
This facility requires a 5-degree course width. Thus, the technicians know that the sideband pad must be changed. Inserting pad widens the course width. Removing pad narrows it. The pad must be reduced, but how much? In this case, 0.4 dB.
November 6-7, Localizer.
Go ahead, Localizer.
Course width has been reduced. Request you make a run to confirm the corrected course width.
Roger, will do.
And so it goes, a pretty regular pattern. A characteristic is singled out and measured. The results are reported and analyzed. After corrective action is taken, it is checked again. This one's complete. So now begins the course alignment check. The check to see if the aircraft on course is aligned with the extended runway centerline, and particularly at the runway threshold. Once the aircraft is at the right altitude, a run is made on the runway centerline extension. There are two ways of aligning the aircraft on the runway extension for the course alignment check. This way, with visual alignment of the aircraft by the pilot, which provides good results in the usual case, and this way, which requires a theodolite for sighting and positioning the aircraft by using ground-to-air communications.
Polarization looks good. We're approaching the outer marker.
Fly right. Fly right. On course. On course.
When the aircraft intercepts the glide slope, it descends on the glide path. As the runway is approached, visual alignment is made with the runway centerline.
Localizer, November 6-7. Your course is displaced approximately 15 feet to the right of center line.
Roger, November 6-7. Stand by.
Even though the course alignment is within tolerance, a realignment will be made. The chief knows that since the antenna orientation is correct, as attested by a recent NOAA test, a slight readjustment of the ratio between the 90 and 150 cycle voltages is required. He knows that he must operate within a specified unbalanced tolerance, If he increases the 150 cycles and decreases the 90 cycles, the course will shift to the left. A slight, careful adjustment corrects the course alignment.
November 6-7, Localizer. We have shifted the course. Will you now verify alignment?
Localizer, November 6-7. Roger, will do. We'll be going into a 6-mile clearance run if the course alignment is okay.
Only after all the parameters have been verified can the facility be published as being completely reliable to the flying public. Every precaution must be taken to see that the pilot approaches the true course and not a false one. Thus, the need exists to determine that an aircraft making an approach to the instrument runway in any location within the usable distance and outside the course width sectors will receive a full-scale indication to fly toward the course.
Localizer, November 6-7.
Go ahead, November 6-7.
We've just completed the 6-mile clearance run and find the facility well within tolerance on equipment number 1. Request transfer to number 2 equipment.
Roger. Stand by. November 6-7, Localizer. Changeover completed.
Localizer, November 6-7. Clearance run on number 2 equipment completed and found satisfactory. Let's conclude this inspection with a monitor tolerance check on both equipments. Please shift the course for alarm condition.
Okay, Fred. November 6-7, Localizer. The course is shifted on number 1 equipment.
The monitor is now being checked for proper alarm setting. This will ensure that a course displacement which exceeds tolerances will cause an alarm. The course width alarm points will also be checked by the aircraft. After the monitor alarm points have been checked, the facility is returned to normal and verified by the flight inspection aircraft. Let's join the technician as he goes over the flight inspection recordings with the pilot. They'll carefully note any unusual areas, perhaps comparing them with previous runs. Any change of a radical nature is discussed and isolated. Careful observation here could reveal a growing problem which might be remedied before operation of the localizer is interrupted. Although the flight inspection is completed, the technician's work continues. He knows that the localizer is now operating properly. So, taking this opportunity to correlate ground readings with flight measurements, he goes back to the facility and checks his list of the many items he must record and evaluate. He logs all meter readings and dial settings. A complete record of the clearances around the localizer array is made on the 200-foot circle. Key measurements are also recorded on the 300-foot arc. These measurements, as well as course position and course width measurements, will be made. When the ground check is completed and the system returned to normal, the notice to airmen is canceled. Only then is the inspection completed for the technician. Only then is his day's work done.